All right, geometry class. Looking at 8.3 and 8.2 and just kind of all of this trig stuff together going forwards and backwards. We're going to put some of this together this week, work on a couple example problems to really try to truly understand what SohCahToa is helping you out with, what it allows you to find. If you're a little uneasy after last week's 8.2, that's completely okay. As long as proportions was a big thing. And then the geometric mean, even if you're a little uneasy on geometric mean, we're going to help you out with that. We're going to solidify that material this week. So, SohCahToa, first, hopefully you watched the video. Let's first truly understand who this legend is. So, Chief SohCahToa helps you understand with trig. So, if you notice S stands for sine. Okay, so sine, OH, SOH, O stands for opposite, H stands for hypotenuse. So SohCahToa, if you can remember to spell that, you'll always remember as opposite over hypotenuse. Cosine, C. A is adjacent, H is hypotenuse. C, cosine, adjacent, hypotenuse. Cosine equals adjacent over hypotenuse, along with tangent. T, tangent, opposite over adjacent. Now, you do not truly need to understand what sine, cosine, and tangent are representing. That is for Mr. Taylor to help you out in pre-calculus, okay? And algebra 2 a little bit as well. You'll get there, okay? The truly understanding where sine, cosine, tangent come from. I am just helping you essentially understand what we can do with them. So, one thing, let's go find those, okay? If you have a TI 8384 calculator, sine, cosine, tangent. Okay, all right there. You will also need what we call the inverses. Notice in yellow, sine to the -1, that's the inverse. Cosine inverse, tangent inverse. Of course, you get those yellow options by hitting the second button. Your phone calculator will have sine, cosine, tangent. Any web browser calculator will have sine, cosine, tangent, and their inverses. So you do not have to have this calculator. It is just what I have here in front of me. Everything has sine, cosine, tangent. Is very popular. Is very useful, as you will come to find out as well. So if we're looking back at 8.2, some quick calculations here. Write each trig ratio as a fraction, as in as a decimal, so they ask you to write cosine of D. Cosine is opposite over adjacent. Opposite over cosine. Adjacent over hypotenuse. So I'm going to go to point D. Okay, my adjacent side length is 8. My hypotenuse is 17. Now remember, the hypotenuse is always opposite the 90-degree angle. So that's my longest segment is 17. Then you have two other ones. You have adjacent or you have opposite in this case. And if you flip back to page 541, it really lays out which one's opposite. Okay, which one's hypotenuse, which one's adjacent. Okay, if I'm here A, B is opposite. If I'm here, angle B, side length B is opposite. C has to be hypotenuse because it's the longest one. Therefore, A is adjacent. So, using that information in practice, we'll be able to really truly identify which side is opposite, which side is adjacent. Hypotenuse has to be the easy one. It has to be the longest one. Identify that first. Okay? So 8.3 here. Solving right triangle. So now we're actually going to go find side length. So I'm going to look at the right triangle trig documents instead. Instead of going through textbooks, so on and so forth, to give you some advice on these questions here. So we want to find the measure of each angle indicated round to the nearest tenth. Okay, find the measure of each angle indicated round to the nearest tenth. So one thing you do have to make sure your calculator is in, and mode-wise, you have to make sure you're in degrees. Okay, I went to mode, okay, and then I went to degrees. That right there needs to be something, most calculators are already in degrees, but make sure they're not in radians, otherwise you're going to get some really goofy answers. Okay, so now, how do we know, are we using angle measurements? Are we using side lengths? What are we finding? So just a point of reference, inverses equals angle measurements. Okay, regular sine, cosine, tangent equals side lengths. That's just kind of a point of reference. So If I'm looking at number 1 here, okay, I'm looking for theta. Theta is an angle measurement, right? So I'm going to be using cosine. I'm going to be using, cosine, because it's adjacent over hypotenuse. Adjacent over hypotenuse. So I'm going to go cosine of theta. Cosine of theta equals adjacent over hypotenuse, which is 12 over 13. All right, something like that. Cosine of theta equals a 12 over 13. Because I'm going based off of the angle. You're always going based off the angle. This is adjacent. This is hypotenuse. I want to find theta. Well, the only way to get theta by itself is to multiply by the inverse. So technically, what you're going to do here is multiply by the inverse cosine of theta, and then if you do something to one side, you have to do it to the other. 12 over 13. These cancel out, leaving you theta equals the inverse cosine of 12 over 13, which is a calculator operation. Inverse cosine 12 divided by 13, enter, 22.6 degrees. Theta equals 22.6 degrees. And it does it for you. It's awesome. Okay, it's really, these are great tools to help you find angles and side lengths. So let's go down here at the bottom. I'm going to scroll down here a little bit more. Okay, I'm going to do a side length example. Okay, I am given this example right here, this angle, 37 degrees. Given this side length is adjacent to it. Adjacent. This is the hypotenuse. It's opposite the 90-degree angle. Hypotenuse. So I have adjacent over hypotenuse, which is cosine. So cosine of 37 equals adjacent, 11 over x. Now, we got a math problem. We got a little bit of algebra. We have a proportion, right? This is why we practice this. So I need to move that x up by multiplication. And one trick you'll learn when you do these problems is if you ever have this down here on the bottom, these two will automatically switch places. Okay, so x equals 11 cosine of 37. That right there. Go to your 11 divided by cosine of 37. Whoops. 11 divided by cosine of 37. Little math problem. Enter. 13.77. They ask you to remember the nearest tenth, so 13.8. 13.8 x equals, and you've solved a side length problem. Notice side length, we kept regular cosine. We did not do any inverse. Notice angle measurements, we used the inverse. Okay, these may seem really a lot right now, but I promise you, I trust you, these will become very second nature. These are awesome problems to become familiar with because they can help you do anything in right triangles. Okay, you guys know how much I love to hunt. I'm using this right now to create my deer blind. My deer blind is going to be awesome. So this sine, cosine, tangent, solving right triangles are wonderful things to do. So of course you have your textbook with example problems. You have your notes with example problems. Reach out to me, okay? As I sent in the email this morning to you guys, reach out to me. If the Zoom does not work and we can discuss this stuff, please do not be shy. Hope to hear from you.